In lesson 44, we're building on what we've been doing with right triangle trig, and we're going to start using it to solve problems. Specifically, we're going to do something called solving a right triangle. So let's remember that if we have sine, cosine, or tangent of an angle, we get a number. We get a ratio. We get the ratio of those sides, fraction or decimal, depending on which way we set it up. Inverse trig means what is the angle whose, in this case, sine is whatever we have in there. That's all that this inverse means. So this one is what is the angle? So the inverse sign has to give us an angle. We've got to remember to label it in degrees so that the ratio of the sides is whatever is in this parentheses. Inverse sign of a number equals an angle, and for now we just do angles with degrees. If we want to solve a triangle, that means we need to know how long all three sides are and how many degrees for all three angles. They must give us some of that to get us started. We have three things in our toolbox that we can use for that. Angles in any triangle, right triangle or not, add up to 180 degrees. If we have two angles, we can use that for the third angle. Pythagorean Theorem. If we know it's a right triangle and we know two sides, we can use Pythagorean Theorem to find the third side. But if they give us an angle, but not two of the angles, and we're trying to find another angle, we're going to need them to tell us enough about sides that we can use trig to get the missing angle. And then we can use triangle sum or trig to get the third missing angle. But our objective is to find all six of those things. They'll tell us some of them. We need to find the rest of the six, and these are the three things that we can use to do that. So let's give it a try. Here is our first one. And on this one, they have labeled one side, and they've given me degrees for one angle. And what else is marked in that triangle? Wyatt? 90 degrees. So I really have two angles. So why don't we start with B? How should we get the measure of angle B, Bella? And that is my triangle sum. So that means 125. If I subtract that on both sides, what do I have to have for B? 55, and it's already got a degree sign in the picture, so I don't need that. Now, shortcut with triangle sum. If one angle is 90 degrees, so it's a right triangle, the other two add to 90. And it's still a variation of triangle sum. But 90 plus the two others is 180. The two others have to be the other 90. So sometimes that's easier math, just to do 90 minus the 35 to get the 55. So are we good with that? Okay, we have side 14. We need side M and we need side X. And it really does not matter which one we do first. So I'm going to do M. So I look at M, and I say, well, what's another side that I know? If I do M and X, that's not going to help me because I've got two variables. But if I do M and the 14, and I now know both angles, but it's better to go with the 35 because what if I subtracted wrong? What if b was really 65 or 45 and I just did my math wrong? Then I'm guaranteed to get m wrong. So if I can use the one that they gave me, that's better. So for the 35 degrees, the two sides that I'm working with are m and 14. Are they adjacent, hypotenuse, or opposite? Summer? Uh-huh. Well, first, is the 14 adjacent, opposite, or hypotenuse? For the 35, is m adjacent or opposite? So for the 35, with m, I'm working with the hypotenuse and the adjacent. So katoa, which one has a and h? Which one works with adjacent and hypotenuse? Cosine. So I write down that the cosine of 35 degrees is m over 14. Now, in any other algebra problem, if you have m over 14 equals something, how do you undo the divided by 14? You multiply both sides by 14. So m needs to be 14 times the cosine of 35 degrees. You enter it on your calculator exactly like that. You don't even need the times button. You just get on a calculator page. I need you guys to do it to make sure you are practicing entering it correctly. And we're going to do 1, 4, no times sign, just trig, cosine, 35, and yes, my calculator is in degrees, which is what I want, and enter. And make sure that this is what you are getting, that you're comfortable using your calculator like that. And then we write that down, rounded to 3 decimal places. 11.468. And that is rounded, so I'm not going to use it for any other calculations. Bella? Technically, it's correct to have it in there, but you don't need to on the calculator. No, I'm not going to count off if you leave it off in your work. I will count off if it's a final answer that needs a degree. Okay, then we continue, and now we need to get x. So for x, 14 is still the hypotenuse. I'm still going to use the 35 degrees. And do I want to use sine, cosine, or tangent on that? For the 35 degrees, the 14 and the x are adjacent, hypotenuse, or opposite. I've had the same ones answering all the time. Jonas. The 14 and the x, because x is, so we're going to write down that the sine of 35 is the opposite x over the hypotenuse 14. Multiply both sides by 14. Type that into your calculators and raise your hands when you have an answer. Anu, what you come up with? Thumbs up, thumbs down, 8.030. Looks good to me. I do want to point out a couple of things on this. You must actually write 14 sine 35. That is how you type it on your calculator. You do not type it in on your calculator as sine 35 is x over 14. You get it to the way you type it in the calculator. Now, I have a right triangle. I know m and I know the 14. I want x. Yes, Pythagorean theorem, but If I use this rounded 11.468 in the Pythagorean Theorem, I can't do that. Once I round it, I can't use it for anything else. I'd have to store it, the whole long messy thing, and do it that way. But it's always much better to use things that are given in the problem and not things that we have figured out unless we have to. Charlotte? It is a set number for each angle. You don't memorize the numbers, except there will be a few next year that you memorize. 30, 45, 60, 90, and so on. But most of them, you're not going to be able to memorize 10 and 12. They're going to be these weird decimals. They are the ratio of those sides. No matter how big or small the similar triangle is, the sides are always in proportion, so the ratio stays the same as long as that angle stays 12 degrees or whatever. Is any question? Jonas, question? Because I found that, and what if I subtracted wrong? It is always best, if possible, use the numbers that the problem gave you. Try to use the 35 and the 14 because the problem gave those to us. Try not to use anything we find unless we have to. Okay, let's try another one. So this time they give us one angle again and the 90 degrees, and they give us one of the sides. So let's do the missing angle first. So figure out what the missing angle up here at the top needs to be, and raise your hand when you have that for me. You know you have the right triangle, and you know you have a 21. Because it says to find the missing parts. Solving the triangle means you end up with all three angles and all three sides. Just because they didn't put a letter on there, it still is a missing angle. You need all six things. So raise your hand when you have that missing angle, even though it is not labeled. Addie, what'd you come up with? Anybody else come up with 69? And the shortcut I just told you would be 90 minus the 21 would be 69. I'm going to put degrees on that because it didn't already have a letter with a degree sign in there. And that was triangle sum. Okay, now using the 21 degrees and the 6.4, because that's what the book gives us, let's find H or Y, and it doesn't matter which one we do first. So let's do H. So look at the 21 degrees. H is the adjacent, hypotenuse, or opposite, everybody. That wasn't everybody, but yes, hypotenuse, thank you. Everybody is 6.4 adjacent to 21 or opposite 21. So if I'm doing adjacent and hypotenuse, which trig ratio? Cosine. So we write down cosine 21 degrees is adjacent over hypotenuse. Now the H this time is in the denominator. And a little trick that you may or may not have learned before, I'm going to think of this as over 1. If you have a proportion, you can pick one of the diagonals, doesn't matter which one, and trade places with those two. So I am going to let the H and the cosine 21 change places. So it looks like this. Now I'll show you why that works on this one. If I had cosine 21 is 6.4 over H, if I multiply both sides by H, then the H goes away over there. And now I have cosine 21 times H, and I want to get rid of the cosine 21. So I divide both sides by the cosine of 21. And then I have what I just wrote down with the shortcut method. Now I need you to punch that in on your calculators. So you're going to do the control divided by, so you get the fraction. in the numerator, you're going to put 6.4. Then you go down to the denominator and you enter cosine 21. And then you hit enter and raise your hand so you can tell me what you get for h. Hendricks, what do you have? So h is about 6.855. Everybody getting that? Anybody having trouble on your calculator? Wyatt? If you do cosine 21 divided by 6.4, it doesn't work. It's different. Correct. Okay, so we have h. Now we need y. So we look at our picture again. For the 21, we're going to use the 6.4 because the problem tells us that number is correct, and we want the y. So 6.4 is still adjacent. Y is what? Everybody. So which ratio if I've got adjacent and opposite? Alexander, which ratio uses adjacent and opposite? Say that again. The tangent is going to do that. So we're going to write down tangent of 21. Is it y over 6.4 or is it 6.4 over y? So y over 6.4. So I need to multiply both sides by 6.4, like we did on the previous problem, and write down for me what we get. Or raise your hand when you've got it, and then I'll write it up here. You can write it in your notes. Ricky, what you come up with? Everybody getting 2.457? Questions with that problem? Okay, I have one last example because it's going to get into something different. Can anybody guess what the next one's going to end up getting into? Inverse tangents, because we haven't used those yet. So this one, they just give me the 90 degrees. They don't give me either of the other two angles, so I can't use Pythagorean Theorem on it. They give me two of the sides. How am I going to get the third side? I have a right triangle and I know two sides. How do I get the third side when that is happening, Bella? Use Pythagorean Theorem. So you guys go ahead and do that for P on this one. You've got the calculators there. Let's 4 root 13 look. Do I want to use 4 root 13 when I'm getting these angles? So what I'm going to do is I am going to use the 12 and the 8. So for x, those are what? Adjacent, hypotenuse, opposite. So which trig ratio for adjacent and opposite? Tangent. I'm going to write down tangent of x is 12 over 8. So I'm going to take the inverse tangent of both sides. I can leave that as 12 over 8, or I can reduce that to 3/2. Tan inverse of the tan is just x, and you are going to punch that in on your calculators. Everybody getting 56.310? Okay, for y, if we do the tangent of y, is it still 12 over 8? No, because 8 is now opposite from y, so it needs to be 8 over 12. So then take the inverse tan of both sides and raise your hand when you can tell me what that is. Baylor? Now, one other thing that you could do if you were really confident in your work, I can't reuse that rounded 56.310. It is okay for me to reuse the entire thing that's in the calculator's memory with all the decimal places that we see plus the extra ones that it remembers. So what I could do is to store that, which if you look right up above the 9 button, you see another button that says VAR. Up above that in blue, it says STO. For the blue things, I need to do Control, Store, and then I'm going to name it. Since that was X, I'm going to say it is X, and I hit Enter. And now if I type the letter X into the calculator, it's going to remember all of that. If I go back to my picture here, I know that X and Y have to add up to 90 degrees because I've got that right triangle. So I could, if I stored it, do Y is 90 minus my stored X, and I like to put a box around it to remind myself that I've stored it. So on the calculator then, I would do 90 minus, and then I'd hit the X because I've stored it, and Enter. It gives me that same angle, 33.690 that we had the other way. Does that make sense to everybody? Think you guys can do that? If it says solve a triangle, it means find everything that is missing. All right, let me just give you the problems